Good morning, guys. Today I'm going to walk you through how to do the latest module that is in the environmental science course for week 4, and that is the climate change module. And specifically, I'm going to walk you through the explore activity, the climate change explore activity. So let's go ahead and click on that. Prior to this point, you've kind of been introduced to the idea of what climate change is and engaged in some information around climate change and its causes. And so this whole unit really is going to focus on global climate change causes and effects. So this first activity is really kind of a lab designed to get your brain thinking around what the Earth is doing, what may be the results of human impact on the climate, and definitely our role in the carbon cycle. So let's click into this activity. And so this is just a screenshot of the virtual lab that you guys will actually participate in. There are 3 parts to this lab, and essentially the lab is going to ask us to change different parameters and see the impacts of the amount of carbon that is being stored in different reservoirs on our planet. And we know from the carbon cycle that carbon moves around our planet as we use it and as nature uses it. It can be stored in different places, used different ways. And so we're going to look at how that storage changes through time. So this actual simulator will take us from essentially 1840 all the way through the year 2100. We're not going to focus on all those years. The lab really focuses around a specific time period. But that is what we'll do. And it's really kind of an easy simulator to use. You make the adjustments. You can either type them in or slide, and then you run it, and it runs by decades, which is every 10 years. And you're going to be asked to record those changes in a data table. And if you mess up, it's super easy, guys. Just reset and apply the parameters again. Okay, and this graph will kind of show you what's happening to specifically atmospheric carbon dioxide in parts per million. And over here shows you what is how much carbon is being stored in these different places. So this is the atmosphere. It gives you the amount, and these are in, I believe, gigatons. Is what GT stands for. So up here, 8.9 gigatons of carbon released, and then the actual concentration within the atmosphere is shown here. It's the only place that the concentration is, which is what this graph corresponds to. Everything else is the amount in gigatons of carbon being stored around our planet. Okay, and each one of these little gray boxes represents 25 gigatons of carbon. Okay, again, it kind of shows you between the years of 1850 and 2015, and have risen from 290 parts per million to over 400 parts per million. That hasn't been seen on the Earth in more than 30 million years. And so we're going to use this simulator and adjust some of the impacts that humans can directly have to see how it impacts the amount of carbon that's on the planet. So this first link right here takes you to the simulator, and you can click on that and it will open it up in a separate tab. And it gives you directions, and these are active links that will take you to each part of the lab. So we're going to do kind of all 3 of these parts, but not all of the parts. There is a data table here that you can use, and it is the same data table. If we go back to the Canvas page, it's the same data table that is right here. Okay, so you can click on it really anywhere. It's a Word document, so you'll open it up in your Office 365, and I have already done that right here. So here's our data table, and you can see we can enter in values as we go through the lab. So pretty straightforward as far as that is concerned. All right. For this simulator, and these are the directions in the Canvas page. This is a screenshot, and the directions for the lab and how you go through it are right here on the left-hand side. So if we go back to the simulator, here's the directions right here. And the first one, the carbon cycle, is an overview, or actually this is the overview that talks about the simulator. And then the first step is the carbon cycle, okay? And it tells you exactly what to do. It says run the simulation to 210 or 2110 with the default settings, and using your data table, record the total carbon levels in each sink, okay? And it tells you which sinks. So we haven't gotten to the actual simulator. These are the directions for the simulator. So you're going to go kind of back and forth between essentially 3 screens, okay? I'm going to open the simulator, and that's right here, okay? And again, that's a third tab. So here's kind of the tabs that we want to go back and forth between. These are the directions. This is the actual simulator. We're going to apply the directions to the simulator and then record that information in our data table. And then at the end of all this, we'll submit our completed data table. Once you have completed the simulation and data collection, click Next, and you will go submit that data table right here, the complete data table. Okay. Now I know it seems like a lot, and really it's not really that much. It's just recording the data down, and you're not completing all of the steps. So don't fear. It's pretty interesting though what happens to the amount of carbon and the impact that we as humans can have on the carbon cycle. Okay. So essentially, you're going to follow through the directions. Using the simulator, you're going to record the data in your data table. And the data table is organized just like in the steps. So, for example, here's that first section, and here is Lesson 1, Step 1, Lesson 1, Step 1, and you're going to record your data here. Lesson 1, Step 2, that would be this link, is going to go right here, okay? And then it will ask you, and this is important, guys, when you look at the data table, so I'm going to go to the data table, there are more than just one question at each of these, but the data table specifically says for which one you need to answer. So don't feel like you have to do them all. Just answer the ones that are required in the data table. Okay? And then in all the sections, there's a little note section down here that you can write information about what you've learned about. And again, we are at this stage in the Explore process. We don't have all the answers yet. We haven't been taught a whole bunch about global climate change. We are starting to make connections to what global climate change is and its potential causes and impacts. Okay? So let's go to the directions, and here's the first lesson. And we'll kind of go through this first one together, and then you guys can do the rest. So in this one, it says run the simulation to 2110 with the default settings, and using your data table, record the total carbon levels in each sink, okay? And it says at 2060 and 2110. So there's essentially 3 years that you have to collect data for, okay? Using the data you collect from the model, answer the following questions while thinking about how the model mimics real-life conditions, okay? Now here's something really important, guys. It says the default setting for the increase in fossil fuel use per year is 2.5%. What that's saying is that it is predicted that we will increase the amount of carbon or the amount of fossil fuels we use as a society by 2.5% every year, okay? And that is one of the settings on this simulator. Right now, here it is right here, adjust simulation parameters, change in fossil fuel use per year. We just read it should be 2.5. Notice, by default, it's set to 2. So what we can do is click in that box, hit 2.5, and return, and it shifts it up. Okay? So now we are set at the right parameter. Okay? And once we run that, okay, we are going to collect, let's look at our data table. We're going to collect data from 2010, 2060, and 2110. Okay? So here's the cool part. You don't have to do anything, okay? Here's the simulator. We don't have to do anything but write down these numbers right here, okay, for 2010, because this is the year. It says right here, this is the year 2010, all right? and a total of 8.9 gigatons of carbon is being released based on these values. So we're going to take these values and write them in. And again, we are focusing on these gigatons. The only one that has the actual concentration of carbon dioxide is here, so we're going to write that too. So atmosphere is 720 gigatons, and the concentration is 391 parts per million. So we're going to go to our data table, come right here to the atmosphere, gaseous carbon, and if we remember, it was 720 gigatons, 391 parts per million. So we're going to write 720 and then 391 parts per million. Okay? Pretty easy. Now, next on the data table is ocean surface. So we're going to do this whole year. Okay, ocean surface, deep ocean. So ocean surface is 1,000. Deep ocean is 38,000. Okay, so 1,000 and then 38,000. Okay, pretty easy so far. Okay, then we're going to come around the horn here and go down here. Oil and gas is at 500. Okay, coal is 3,500. So oil and gas 500, coal 3,500. Oil and gas 500 and coal 3,500. Now let's think about that for a second. What it's showing us, right? It's saying there is a ton, more than a ton, gigatons, 3,500 gigatons of carbon are tied up in coal. And that seems like a lot, but check out the deep ocean. There are 38,000 gigatons of carbon dioxide carbon stored in the deep ocean. Okay, so a much bigger reservoir here. All right, now check out soil for a second here. It says 1,800 plus 200, and it's important that we look at both of these numbers, okay? And these numbers are dependent on things like deforestation, so we want to write down essentially the sum of those two numbers. So soil is 1,800 gigatons plus 200, which gives us a grand total of 2,000 gigatons, okay? So we're going to put that in our data table for soil, 2,000, okay? And then last but not least, terrestrial plants at 700, okay? Now, as we adjust these values, we go through the decades, we're going to see these numbers change, and we're going to put those in our data table. So let's finish this one. Terrestrial plants is 700. Okay, and now we're going to go to 2060. That's the next data point that we're looking for. So going to our simulator to go to the next decade. Okay, again, we made sure that we're at 2.5% increase in fossil fuel use, and we're going to hit the run decade. And you have to click it for each one. It's not like it just goes and you have to stop it. So that is 2020, 2030. Okay, and we can see that these values are changing here. The graph is taking a different standpoint. We're seeing these values change, okay? Some numbers are going up, some numbers are going down. We're going to keep going until we get to what value? 2060, right here, 2060, okay? So keep going, run decade, 40, 50, 60, okay? So this is saying that in the year 2060, assuming that the amount of fossil fuel consumption increased by 2.5% each year, this would then be the location and amounts of carbon stored in the different reservoirs on our planet. Okay, so notice we have this value here now, and we essentially release 273 gigatons of carbon into the atmosphere by burning fossil fuels. But our data table specifically wants to know what these values are. So we're going to, again, go around the horn, okay? So atmosphere is 1105, and carbon dioxide is 610, okay? 1105 and 610, so we'd come here, 1105, and then 610 ppm, okay? Ocean, all right, is going to be 1123, so we take this 1,000 plus 123, that's 1,123. Okay, we'll put that into our table. Okay, and we just keep filling in the data points. We have 3,800 or 38,000 plus 270 gives us 38,270. Okay, we just add those numbers together. 38,270. Okay. All right. What do we notice? We see the atmospheric concentration has almost doubled. The amount of gigatons of carbon in the atmosphere has increased. Same with the surface ocean, same with the deep ocean. As we work our way around, look at oil and gas. That one didn't increase. Okay, so that's 0. Coal is 3114. Okay, so oil and gas went to 0 and 3114. Interesting, like look what happened. We increased the amount of fossil fuels by 2.5% over the course of 50 years. This is a 50-year difference. And look what happens to oil and gas. Coal, okay, notice what happens to coal. And then looking at soil, soil increases to 1800 plus 242 gives us 2042. And then terrestrial plants is 766. So 2042 and 766. 2000. Hang on, let's check that again. 2042. I was right. 2042, 042, and plants was 766. Okay, so now we've got this. We see that plants are increasing the amount of storage of carbon. The soil is increasing a little bit. Coal reduced the amount of coal that is available. As far as carbon in gigatons has reduced, okay? And we can keep doing this, okay? So the next point on our data table is 2110, okay? And you guys would adjust your values to, click the run decade till we get to 2110. That's another 50 years. There's 80, 90, 2100, 2110, okay? And here we are. And you're going to take those numbers just like we did before, and we're going to put those into our data table. I'm not going to do that right now, okay? So we finished this first part. Let's look at our data table, okay? And it says response to question 1 only. So we got to go back to our directions, all right? And here's step 1, question 1 right here. If only 1/2 of the flora in the world existed in 2110, okay, perhaps due to deforestation, what do you predict the atmospheric carbon level would be? How would you change the simulation to reflect this? Okay, so it's asking if we lost half of the forests, okay, by the year 2110, what do you think would happen to the amount of carbon that's floating around in the atmosphere? Okay, think about what plants do with carbon. And then how would you change this? So looking at our simulator, how could we change something on our simulation to help us predict what that might be? Okay, so is there a setting over here that we can change that might simulate, okay, what if we reduce the amount of forests and plants and terrestrial plants that are on our planet? Can we do that and then run this simulation again and see what would happen to this atmospheric carbon? Okay. And then you're going to put that response right here in the in this spot, response to question 1 only. Okay, this data table is for step 2. Okay, so we're going to go to the lab, look at step 2, and again, there's more than one question here. Look, there's 2 and 3. You don't have to worry about those. I encourage you to look at them, read through them, make some predictions. It's only going to help you in the future here. But you don't have to put an answer down for those. The one you have to put an answer down for is this first question. Looking at step 2, this is going to be the second part of this data table right here, okay? And it says, okay, in many scenarios, the atmospheric concentration of carbon dioxide is projected to increase beyond 700 parts per million by the end of the century. However, this increase in atmospheric carbon doesn't account for all the carbon released by burning fossil fuels. To find out where all the carbon really goes, run the simulation again, 1 decade at a time, record the total amount of carbon in the atmosphere, the number in the sky, and the other carbon sinks as carbon moves through the system. Note that 1 part per million of atmospheric carbon dioxide is equivalent to 2.1 gigatons of carbon. As you record your data, keep in mind that this is a simulation of real life. Think about the questions below. Okay? So, looking at our data table, essentially we're going to take the information here. We did this by 50-year increments. Now we're going to do it by 1-year increments. So, here's a quick little hint, guys. Go ahead and take this value right here, okay, all those, and just copy them, okay, copy, and then put them right here, okay, and then paste, Oh, it wants me to use my shortcuts, Apple V. All right, let's do this again. Okay, the cut and paste isn't working, so just repeat them. Okay, 720, and then 1,000, 38,000, 500, 3,500, 2,000, and 700. Oop, hang on, what did I miss here? Oh, look at this, guys. There's a smokestack, so we got to move all this stuff over, okay? It now wants us to record this value right here that comes out each time. So let's reset, okay? And then looking at 2010, there's nothing coming out of this smokestack right here. So this value would actually be 0, okay? This is the one that would be 720, 1,000, 38,000, 500, 3,500, 2,000, and 700. Okay? And then you would repeat these numbers 2060 down here in this value, but you're going to have to run the simulation just to get this value, okay, to put it in there. But the values here would be 1123, I'm sorry, 1105, 1123, 38,270, 0, 3114, 2042, and 766. Okay, so let's go ahead. We'll do this one together. Okay, let's go ahead and do this 2020. So we're back at our model. And again, we're making sure we're at 2.5%. We're going to run it for 1 decade. That's 10 years. Okay, and the purpose of this, guys, is so that you can see this is in like 50-year increments, and it's really hard to see like where the carbon went and how it went there. When you look at it by 10-year increments, you can kind of follow each one and see what's happening with each carbon sink. All right, so here's our simulator. We're going to run it for 1 decade. There's 2020. We're going to record these values. So we now are recording this value as well. So this is 102 gigatons came out of factories. Okay, and then we're at 755 in the atmosphere. Okay, so 102 and 755. This is going to go here, 102 and 755. Okay, and then we just keep rolling. And again, if you want, you can continue to add the parts per million in there. If you want, it's going to make your table bigger, but that's fine. In this case, it's 417. Okay. All right. If you don't want it to, I think you can. No, you can. So it'll make your table bigger if you choose to include that value in there. But again, you're going to record everything in here, and then looking at these questions, okay, what did you notice about the relationship between the increase in fossil fuel consumption and increased carbon in terrestrial plants? How might this change flora populations? What impact could 20 years at this level of consumption have on flora? Okay, so again, you're not responsible for those questions. Really, it just wanted that first one from step 1, and you're going to just type that answer in here. I think that reducing the amount of forests would have this impact, okay? And you can write any notes here, what's happening. I noticed, look right here, I noticed that in 50 years there's no carbon, there's no oil and gas. In 50 years, there is no oil, no carbon in the form of oil and gas. And those are natural deposits. Okay. Fix my typos. And that's just 50 years. Okay. So you can write little notes there. It's really not important what goes in there, just things for you to recognize. All right, then you're going to go, so you're going to complete this whole data table, okay? And I encourage you to look at what's happening to each one of these storage places for sinks for carbon and how they're changing based on human consumption. Again, this is all about predicting what will happen if we continue to increase the amount of fossil fuel usage by humans. Okay, not changing anything else, just increasing the amount of fossil fuels that we're using. Okay, so then the next part is in the data table is this curb your emissions section. Okay, so there's a little bit of an overview. In the best case scenario, imagine that scientists suddenly discovered an unlimited, clean, and cheap fuel source that emitted no carbon dioxide in the atmosphere, thus bringing fossil fuel use down to zero. What would happen? Would the carbon cycle naturally bring atmospheric carbon dioxide levels back to pre-industrial levels, below 280 parts per million? Press the None button next to fossil fuel use to bring CO2 emissions to zero in the simulation. Then run the simulation for 100 or more years to see what happens. Record your data and compare it to your previous entries. Okay? So step one, all right, we're going to, according to the directions, so let's reset our model. That's really important. Each time you need to reset your model, you're going to come over here to None, okay, and set that to zero. That means there's no use of or no production of carbon dioxide from fossil fuels, okay? And then you're going to run the simulation again. If we look at our data table, okay, step two, we want you to run it in 50-year increments, just like we did last time, okay? And so we're looking at just the atmospheric carbon, ocean and surface, and the soil and terrestrial plants, okay? So we're not looking at fossil fuels anymore, okay? So let's come over here, and we're going to run that till, sorry, we need to put these values in, 2010, so we need to put these values in. We're at 720 and 391, okay? Same as before, okay? So you've got that data, all right? 720, 391 parts per million, okay? Ocean and surface, ocean is 1,000, okay? Deep is 38,000. Sorry, it was 1,000 and 38,000. And 38,000. And then it just wants soil and terrestrial plants, so we're skipping this part and looking here. It's 2,700. And again, this is already in your table up here, okay? 2,700. All right, 2,000 and then 700, okay? And then we're going to run it for 2060 and do the same thing. Here's our simulator. Now, though, we don't have any fossil fuel carbon dioxide production. So 2060, I believe, right? Yep, 2060. 40, 50, 60. Check out the graph down here, guys. Look what's happening. So this was the historical. If we stayed on our current path, and we noticed that from the last simulation that we did, we stayed right on this path. But now we found this new clean energy that doesn't produce carbon dioxide, and look what happens. All right, look at this. This is zero. Look at these values, okay? These are the values that you're going to put into your data table, okay? So 652, okay? What happened? Look at this, 652, and the parts per million is 360, okay? All right, what do you notice? What's happening, okay? And we want you to do this for each one of these, running each year. And again, remember, we created we found this new fuel source, doesn't produce any carbon dioxide, and we're wondering if if naturally the Earth would return the amount of carbon dioxide in the atmosphere to below pre-industrial, that's before the industrial age, okay, to levels below 280 parts per million. And just kind of anecdotally, guys, if you're looking at the news at all, and today being Earth Day, there are tons of places, especially places like China, that are seeing, like, the air pollution is almost completely gone because people aren't using their cars while we're home. And it's pretty impressive how fast the Earth can start to heal itself if we just allow it. So you're going to run through these particular, that simulation. Again, you're going to go another 50 years and record those data values down, okay, and looking at our data table, okay. And this time it wants us to respond to the questions, okay. So let's look at those questions. How have atmospheric carbon levels changed without any fossil fuel consumption? Which parts of the cycle have improved their carbon levels in comparison to previous data? what sections of the cycle have improved from the previous levels you've recorded but still are increasing their carbon levels. So what I found the best thing to do is just copy this, okay? And you can go to here, copy, and then come over to your data table, and you can put them right in to your data table right there, and then just respond to them, okay? If you want to make this like an answer, you just hit this little tab, increase indent, and there's your answer. How have atmospheric carbon levels changed? They have ... without any, okay? So you can run this simulation and then answer the questions, okay? So that's part one of the second part of the simulation, okay? Lesson 2. Now we're gonna need to go to lesson 2. Again, you're gonna complete this data table for step 1, then step 2, okay? And step 2 is right here. And now it says you saw in step 1, yada, yada, yada. Reducing carbon emissions to 0 is far from realistic unless we actually do find something that produces no carbon dioxide, which is probably not possible. If you invent it, you'll be a millionaire for the rest of your life, and super famous. Then, what's a more realistic value? Many scientists agree that doubling of the pre-industrial CO2 to approximately 550 is a reasonable target to shoot for in order to avoid the most serious impacts. So you're going to return to your simulation and change the annual percentage to increase fossil fuel usage until you can keep atmospheric carbon dioxide concentrations below 500 parts per million in 2100. Okay, so it wants to know, okay, let's see, once you have found an appropriate level of fossil fuel percentage increases, predict what would happen if fuel use stayed at that percentage increase and deforestation decreased. Okay, so the first step of this is to try to figure out what is the sustainable use of fossil fuels, okay, that would keep carbon dioxide concentration levels below 550 parts per million. And then once you determine what that is, if deforestation was decreased by 50%, how would the carbon levels in the soil change? Okay, run your simulation to test your hypothesis. Okay, so the first part of that is, okay, we know we can't live at 0 here, so let's reset. And what we're shooting for is let's read the directions again. By 2100, we want our carbon dioxide values to be below 550. Okay? Well, we know that at 2.5%, okay, that we were already above that by 2060 in 50 years, not even 100 years. So we know it's going to be below the regular 2.5%. So you're going to just start playing with this number, okay? These are negative numbers, so this would be no change. This would be no change. 0 would mean that we are not increasing nor decreasing the amount of fossil fuels that we're using. So let's start there, nice number, and we're going to run it. Again, we want to see what it would be at 2100 right here. This is what we're focusing on, okay? So we're going to run that simulation, run decade, and we're going to go to 2100, okay? Not looking bad. Again, we want it to be below 550, okay? And that's what this line is denoting, okay? By 2100, we are at 504 parts per million, okay? Now, is it realistic to not use any more or any less fossil fuels? Maybe, but the number of humans increases each year, so I think you can run around this number, just adjust this. You can keep going up. It's going to be less than 2.5, but it's definitely can be above 0, so we can tolerate some increase because we're still well below that number, okay? So figure out what that number is. Once you have determined what that number is, then that second part said, okay, now that you know what that number is, in 50 years, if deforestation was decreased by 50%, how would the carbon levels in the soil change? Okay, so run the simulation. How would the carbon levels, run your simulation? The best way to run that simulation is to start playing with this number. So let's just say that 0 is the number. Okay, it's not. Just let you know it's not. Okay, but let's just say it is. So I'm going to reset. I'm going to keep this at 0, and now right now we use 1 gigaton. There's 1 gigaton of net deforestation that happens. Well, the question is asking is, what if we reduce that by 50%? So what's half of 1? we're going to go to 0.5. Okay, and then we're going to run the simulation for, what does it say? It says once you have found this, in 50 years, okay, in 50 years, if deforestation was decreased by 50%, how would the carbon levels in the soil change? Okay, so I've reduced this by, we were at 1 gigaton, now we're going to reduce it to 0.5. Okay, so run the simulation for 50 years. Okay, so 2010, 30, 40, 50, 60. There's 50 years. What happens to the concentrations of carbon in the soil and in the plants? Okay, based on this new value. And you're going to put that into your table in part 2 right here. Okay, pretty straightforward. And then you're going to answer the questions. Okay. And again, you're just going to cut and paste those into your data table and answer them. Okay. The last part of the lab is step 3. Okay. And in this one, we are going to look at our directions. So come back here. Here's step feedback effects. Okay. Step 1. We've considered the impact of burning fossil fuels. Okay. Currently, land use and deforestation outstrip reforestation by roughly 1 gigaton. If deforestation were to increase, perhaps due to increased burning of rainforest, carbon would be transferred first from terrestrial plants to the atmosphere. Change the net deforestation rate and observe how that impacts the carbon cycle. Note that deforestation is expressed as gigatons of carbon released, not as percentage rate of increase. Realistic deforestation estimates would remain less than 2 gigatons per year. Record what happens to the system at a steady net deforestation rate of 1.6 gigatons per year and answer the following. So we are setting the model to 1.6 based on our current carbon production through fossil fuels. So we're going to reset our model. Anybody remember what that value was for how much we use fossil fuels? It was 2.5. Okay. And then we are going to set our deforestation rate at 1.6 gigatons. So we're going to come over here and 1.6. So in the first round of this simulation, we had this set at 2.5 for change in fossil fuel use per year and net deforestation of 1. We are now increasing our deforestation. So we're looking at the impact of, while we aren't burning more fossil fuels, we are clearing more land, deforesting more land. All right, think about the role that trees and forests play in the carbon cycle. All right, and start making some predictions about what might happen to the carbon in these different pools or sinks. Okay, so then we're going to run our simulation. It says record what happens to the system at a steady net deforestation rate of 1.6. So looking at our data table, we're going to run 2010, 2060, and 2110. Okay, I'm sorry, right here. I was in the wrong table. This table right here. Step 1, 2010, 2070, 2090, and 2110. Okay, so 2010 we already have up. It's right here. There's our values. We're going to write those in. 720. We've seen these numbers before, guys. 720, 390, all that great stuff. Okay, that's going to go in this first row right there. Okay, and the net deforestation rate in this case is 1.6. Okay. So our soil would be soil and terrestrial plants. We're only looking at these two. Is going to be 2,000, right? Those two numbers added together, and 700. Okay, and then we're going to go to 2070 and see what that change is. So run the decade. Okay, check out the graph. Look what's happening here. Okay, 2070 again. We're going to look at these values right here. We're now up to 2,064 and 797. Okay, what's happening to the carbon that is in what we call the biosphere, the soil and the terrestrial plants? And then that's still 1.6. This is going to be 1.6, and this is going to be 1.6. Okay, so you're going to record those values there. Okay, looking at the questions. Okay, and again, there's no, it just says all questions here. So we're going to cut and paste these questions into our response to questions. There they are. Okay. How has the terrestrial flora population changed? What is the carbon level in the soil, and how does the carbon level affect the flora populations and species variety? Okay. So you're going to answer those questions based on the data that you collected. Then you're going to go to step 2. Step 2 has some other things, and it talks about this tundra melt. Okay, there are several important natural systems that may be affected by greenhouse warming. Okay, so you're going to run that. You will find 2 possible scenarios. One model assumes that 1/12 of the tundra will melt over 100 years, and it's due to increased temperatures. The other predicts that 1/6 will melt over the same time period. Assume that in this hypothetical scenario, the tundra melting is inevitable and there's a 2% increase in fossil fuel consumption. Which of the 2 melting rates would have an impact on coastal seaweed populations in 2060? How great an impact? Okay, so essentially we have to change a different value. Now, in order to change that value, notice there's no tundra melt up here. You want to come up here, okay, and go up to Tableau. Okay, you can also come here in Feedback Effects. It will do the same thing. Okay, we want to see that tundra melt. Okay, so go to Feedback Effects. Okay, and here's Melt Tundra. Now we have the ability to adjust the amount of melting tundra. But let's look at our parameters again. Okay, assume that in this hypothetical scenario, the tundra melt, and we want to look at it for 100 years. Okay, the tundra melting is inevitable, and there's a 2% increase in fossil fuel consumption. Okay, which of the 2 rates of melting would have an impact on coastal seaweed populations in 2060? Okay, so let's go here. We're at 2% already. That's perfect. This is staying at 1, and we're going to pick one of these values, either 1/12 or 1/6. Okay, which of these is a bigger number, bigger impact? Okay. Remember that the larger this number is, the denominator is, the smaller the impact. So, or the smaller the value total. So 1/6, okay, is a bigger number than 1/12. So let's do that one. And again, we want to run it for 100 years, right? So 2010 to 2011, or 2110. There it is, okay. And we're going to record our values. We needed to record the 2010 values here. All right, so let's reset that. Okay, reset. Okay, we're back to 2010. We need to, and we're at 1/6. We need to record these values again. Same numbers, guys, that we've been seeing. And the data table wants the net deforestation rate is 1. We know that. We chose 1/6, so we're going to put an X here. Okay, and then the atmosphere is, what was it? 720. $1,000. Deep ocean was 38,000. And you guys can fill in the rest of these. Okay, and then we're going to go to 2060. That's what it wants. So let's go to 2060. There's 2060, and we're going to record these values. Okay, 1044. This is going to be 1110. We're at net deforestation of 1. We're at 1/6. What was that value? 1044 and 1110. Okay. And you're just going to keep recording those values. And then you need to look at these questions. Okay. Assume that in this the tundra melt, which of the two rates of melting would have an impact on coastal seaweed populations in 2060? Okay, so once we've collected our data, okay, looking at 2060, what's going to happen to our surface ocean, our deep ocean? It asked us about seaweed, okay, not terrestrial plants, seaweed. So looking at where does seaweed exist and what might happen there. Which of the 2 rates of melting would have an impact on the atmospheric carbon in 2110 that is similar to another scenario you've investigated? what commonalities exist between these two scenarios, okay? So what that's asking you to do is look back at your data from these other lessons, and did this setting of 1/6 in the simulator of tundra melt, okay, that means that much tundra is melting each year, did that have a similar impact to maybe us deforesting something, or maybe us increasing or decreasing the amount of carbon dioxide we're producing by making fossil fuels, okay? So once you've completed your table, you got all your stuff filled in, okay, you're going to save it, and then you're going to come back to the Canvas page, hit the next button in the module, and submit that assignment, okay? So hopefully that walks you through how to use this simulator. If you have any questions, just reach out to your teacher, and they'll be more than happy to help you out, okay?